14th STEM Wednesday. It's crazy to think we've already done this for 14 weeks. So it's exciting. Thank you all that are coming back time and time again. And for all of you that are spreading the word as well. So we want to continue doing these. So anything, if you can share it with other people, or if there's maybe a topic that you would love covered, if you've been coming to a lot of them, let us know. Today's speaker is Jillian Dale. She's the Mimeo STEM. Technically, her role is the East Coast sales representative, but she has a lot of different hats. She's a former teacher, and Jillian, I believe, former program director of, it was STEM for Girls, right? That was a Indiana organization.
That's correct.
So I will hand it over to Jillian now. Thank you, everyone, for joining us.
Awesome. Thanks, Braden. Well, hi, everybody. Thanks for joining me today. Today, we're going to talk about building number sense with your 3D printer. We will go over, kind of what number sense is, and then some different number sense strategies and landmarks that you can use to support your math instruction, some 3D printed manipulatives that you can use to start building those number sense strategies, and then the benefits of using 3D printed manipulatives as well. So thanks, Braden, for the introduction. Like we said, my name is Jillian Dale. I'm a former teacher myself. I taught 4th grade math, and then I also taught K through 8 STEM. And when I was in college learning to be a teacher, I really just fell in love with math pedagogy, how children learn, the learning progression of computational fluency, just all of the math components I really, really loved. And so I did a whole bunch of research on it and continued to develop my math instruction. And now here we are. So my first question for you guys is, have you ever used a 3D printer before? So I'm going to go ahead and launch that poll so that you can answer that question. Okay, the poll is live. Have you ever used a 3D printer before? Awesome. Thank you, everybody. So it looks like we're kind of split, 50-50. Some have used it a few times, and then some have never used one before. So that's fine. So we're going to talk about just some of the benefits of using these 3D printed manipulatives and how you can use them in your math classroom. So what is number sense? Number sense is building an understanding of numbers, quantities, and how they relate to each other. And I found this quote, and it really puts it, pretty black and white. Number sense is a good intuition about numbers and their relationships. It develops gradually as a result of exploring numbers and visualizing them in a variety of contexts, relating them in ways that are not limited to that traditional algorithm. So kind of breaking it out of how a lot of us probably learned math growing up. If we can follow a procedure, then we can solve the problem or solve the equation. And that's just not working anymore. And so we have to make sure that we're, organizing our classrooms so that we're making the learning accessible to all learners. And to do that, we have to start with building their number sense. So number sense is important because it builds that mathematical reasoning to encourage authentic application. So in order for kids to know what math strategy they want to apply to the problem, they have to have an understanding of what that math strategy actually does. And if they're only taught procedurally through the traditional algorithm, then that's not really an authentic application. And it also lays the foundation for building a true understanding of quantity and relationships, how they relate to each other within all mathematic concepts. So here's a list of number sense strategies that I just kept handy when I taught 4th grade math, because in today's math classroom, you may have kids that are working 2 grades above your grade level, and you may have kids that are working 2 to 3 grades below your grade level. So you have to make sure you have a ton of strategies in your back pocket to be able to make the classroom accessible to all of those learners. So some of these strategies that you'll see on here are, pretty intuitive. You know what counting is, you know what counting backwards is, but some of them you might be unfamiliar with. So we're going to break down some of these strategies today and talk about some 3D printed manipulatives that you can use to help support these strategies or skills, and then just other ways that you could start building that foundation of number sense. Okay, so the first one we're going to talk about is called hierarchical inclusion. And it's basically an understanding of that a quantity also represents all of the quantities behind it. So I've heard the term 5ness when you're talking about the number 5. 5ness, it means that within 5, it's also 4, 3, 2, and 1. And it helps students build an understanding of part-whole relationships and also of compensation. So some strategies that you could use to support this landmark is going to be counting on, counting one more or one less, decomposing a number and asking the students to find a number within that number. And you can easily do that with the stacking blocks kit that we have on mystemkits.com. Build a row of 7 and ask the kids, to name 2 numbers that are within that 7. There's lots of different things that you can do. And I put the Russian nesting dolls on here because it always reminds me of the Russian nesting dolls, because one contains, multiple ones within it. The same thing is true for numbers and quantity. Okay, counting and cardinality. Counting, just knowing the names of the numbers and the sequence, the order that they go in. And then cardinality is knowing that the number that you counted represented the actual number of objects. So if you count 6 counting bears, you know that there's actually 6 there. So that's an important strategy that they teach in kindergarten. And an easy way for you to start, implementing some of these strategies is going to be counting on your one-to-one correspondence, which is like one-to-one tagging. So the kids counting through things and touching each one. Counting backwards, skip counting, and then I really, really like subitizing. Subitizing is being able to look at a quantity and knowing exactly how many are there. So if you think about like dice, it's really common to know like this equals 5. We've seen dice so many times, like it's easy to know that when we look at that pattern of dice, it represents 5. But it may be a little bit more difficult for you to recognize this quantity. Not necessarily difficult, but just may take like a fraction of a second longer. And that's because it's not a pattern that we're super familiar with. And so when students are able to recognize some of these patterns, they start translating those patterns into other areas of their math classroom. Okay, benchmarks of 5 and 10, such an important number skill. It's understanding that there are friendly numbers within the number line that you can rely on to help you solve problems quicker, right? So think about those friendly numbers. It's much easier to add to your 5s and 10s than it is maybe like your 7s or your 3s. And also with benchmark numbers, no number is ever more than 2 away from a benchmark number. So like the number 47 is 2 away from 45. The number 48 is 2 away from 50. So it's an important understanding for kids to know that you can always find a benchmark number quickly. And if you can add or subtract 1 and 2, you can use those benchmark numbers to help you compute faster. Benchmarks of 5 and 10, essential when you are teaching estimating and rounding. I mean, it is so important for students to understand how a number line works in order for them to know how estimation and how rounding works. And it's a hard skill to teach, but manipulatives make it easier. And here's some manipulatives that you can use to help with those benchmarks of 5 and 10. So the 10 dot frame kit is basically a 10 frame that you would print, and then you just print the little pieces that fit inside. You can use this to help you find those friendly numbers, decompose 10s, help kids, even algebraic expressions. You can help them sort out what the expression would be based off of the base 10. The bowling kit that we have, since there's 10 pins, super, super easy way for you to start incorporating benchmarks of 5 and 10 in your small group instruction or in your whole group instruction. And then there's lots of things on Thingiverse too, like the Rec and Rec, that can be, printed off of Thingiverse and then used in your classroom as well. So there's lots of different things that are out there. You just have to use them, get them in your kids' hands, and then they'll start benefiting from them. All right, next concept, another super important concept when that students need to have a good foundation of before they can move on to multiplication or division. Those are really hard algorithms for them to know if they don't have a good understanding of part-whole relationships. So part-whole relationships basically is an understanding that numbers are broken down into parts, right? So a whole number can be broken down into various parts. So it helps build that conceptual understanding of computation And then it also is going to increase your flexibility with these quantities. So you'll be able to manipulate those numbers a little bit more in order to make them easier to compute. Some good kits that are already on my STEM kits that are going to help with fractions. They're going to help with long division, with multiplication. The parts of a whole kit, great for teaching fractions, decimals, and percents. The partitioning whole numbers, great way to introduce fractions and early concepts of division. Okay, spatial reasoning. Spatial reasoning sounds complicated, but it's really just being able to visualize quantities, patterns, shapes. It doesn't necessarily have to be geometry related because it's putting a visual representation onto your quantity. And it is essential for students to master that if they're moving from concrete ideas to abstract ideas. When they're doing subtraction or division and you start them out by, let's just say, using counting bears or some other counters, and you're starting with a certain quantity and you're taking some away, that concrete idea of subtraction, that's great for kids to know, but they can't move on to that abstract or the standard algorithm for subtraction without first having that basic understanding of those concrete ideas. And a great way for students to do it is by having those manipulatives in their hands. That's going to increase their spatial reasoning, and it addresses multiple learning styles as well. Okay, my next question for you guys is going to be, what is your particular learning style? So let me launch this one. There we go. Okay, so what is your learning style? Like linguistic? Do you, oops. Sorry, technical difficulties. All right, so are you more of a person that enjoys reading information out of books? Logical, do you think more of a math brain type person? Visual, you need something, in front of you, an example in front of you. Bodily kinesthetic, are you a tactile learner? Do you want something in your hands? Intrapersonal, do you prefer to learn on your own and master things on your own? Inter, do you prefer to work in a group? Naturalistic, do you prefer to, learn not necessarily outdoors, but just different concepts that involve our natural world? So think about those types of things. Musical learner, that's also another possibility.
Jillian, I realized I left scientist on the headline.
That's okay.
Of that poll.
Yeah, I was a little confused at first, but I found it.
Well, we got the gist. That's good.
Yeah. All right, so I'm going to go ahead and share these results with you because I want you to see just how many people said that they were a visual learner. Lots of us, we want to put the bookcase together before reading the directions. We want to just, look at something and then figure things out on our own. And that's very natural for students as well. And the great thing about STEM that I love is because you can address so many of these different learning styles in your STEM classroom. Just on one project, you may have intrapersonal learning, interpersonal learning going on. You may have some logical learning going on. You may have some linguistic going on. And then you're definitely going to have some kinesthetic or tactile learning with these things in your hands. So there's just so many different benefits to addressing multiple learning styles through STEM education. And there's lots of benefits for 3D printed manipulatives as well. It's cost effective. It's going to be so much cheaper for you to print a class set of manipulatives than to go purchase a class set on Amazon. We're talking like hundreds of dollars of savings. Customized designs. Have your students, work in Tinkercad to build something that may work for them. Instead of working on a 10 frame, maybe you need a 15 frame or a 25 frame. So we can, make sure that it is addressed to our students' particular needs and learning styles. It's hands-on. My students were so much more engaged when I had something in their hands because a lot of them were that tactile visual learner. Like I said, actively engaged. Students, they're intrigued more by it. They feel more included in it, and they get a little bit more excited about learning that. Good for spatial recognition. Okay, so they're visualizing some of these concepts that are hard to do. So it's a great way to assist students in visualizing and working on those spatial reasoning skills. And of course, my favorite one, it sparks interest in STEM. when children see that they're using something that maybe you 3D printed on your own, or if you had another group of students create this 3D printed manipulative in Tinkercad, what a great way to spark interest in STEM, even outside of the math classroom. I mean, there's so many different things that you can do, and it's just going to get these wheels turning for your students. Okay. So the last thing I wanted to show you is some of my resources that I've used over the years on just familiarizing myself with number sense, the benefits of learning number sense, learning progressions, all of that good stuff. The Recovering Traditionalist and by Christina Tondevold, she's great. Her website has a ton of different resources for you, including number sense skills assessments, different games that you can play. Graham Fletcher, if you're looking for information on the learning progression, so how students learn addition, starting with, 1 plus 5, all the way up to the millions, he represents it in such a great, easy way for you to understand, and then start building those strategies out to support your kids. Dan Meyer wants to flip the mathematics classroom and make it more accessible to all learners. So I highly recommend that you go and check out some of his stuff as well. And then U Cubed is represented by Stanford and Joe Boaler, and their website has just a ton of different information and strategies that you can use for all ages, not necessarily at the kinder or the elementary level, but all the way up to the collegiate level. And then some of the authors that I love, you can see that I put some of the books that are on here, but Kathy Fosnot and Martin Dolk, those are both phenomenal authors in terms of understanding number sense and how we build it in the classroom. Van de Waal, and then of course Joe Boaler, and then the Cognitively Guided Instruction, their whole series by Carpenter, Levi, Empson, Fennema, and Franke. Their whole series that they have on just cognitively guided instruction. We're talking number sense, we're talking problem types, all the different ways that you can support learners individually. Their whole line is just amazing, different books that you can find that you can start using their strategies tomorrow. Tons of different online resources that come with the books as well. So just really, really valuable in terms of your math instruction. Okay. So thank you for attending today's STEM Wednesday. Happy National Day of STEM also. I'm so glad that you were here with us today. The printed materials that I showed you today, those were all printed on our Robo E3 printer. Super easy to change out the filament so that you're printing in multiple colors. To sign up for next week, you can go ahead and check the chat. Braden just posted a link in there to sign up for our next STEM Wednesday. And if you have any questions, I'll be sticking around in the chat. And as always, thanks for attending STEM Wednesday.